Welcome to Module 3, Lesson 17, the area of a circle. In this lesson, you will take a look at the relationship between the circumference of a circle and the area of a circle. Okay, it's very interesting and kind of an aha moment for me when there's a video that I have posted at the website that follows, that I'd like you to view following this lesson. It gives you a very, very interesting perspective or background on the idea of the area of a circle and how to actually calculate it, and the formula itself. And we'll get into that as we move through this lesson. Also going to show you how the formula for the area of a circle is actually completed, and also how we use it to solve problems. Okay, but let's get a few reminders before we move on. Not that you need reminding, but just the definition again of a circle, the set of points of all points in the plane that is denoted by the center point C, and a radius which is greater than 0, that our distance r from point C. Okay, so the circle part, has something to do with r and C, because they with their help, the circle is designated, but the circle is, and we have talked about this already, it's just an interesting thing to know, is the set of all of these points. Okay, and again, we had talked about, these points can be, not infinite, but pretty close, and that video I had told you about that I would like you to watch after, that is posted at the website, will show you something very, very interesting and related to that. Now, again, that's a definition of a circle. That's what we know about a circle. Now, the circumference, okay, as we know, and most of you do know, is the distance around that circle. Okay, so that circle, that distance, okay, is the circumference, and you can think of it as circumference, okay, circumference all the way around, and I'm sure you know that, but I was told to remind you. Okay, so let's get started in earnest here with lesson 17, the area of a circle, with these exercises 1 through 3. So exercises 1 through 3 ask you to solve the problem below individually. That should be problems, I'm thinking, and then explain your solutions, I'm thinking. Anyway, I'd like you to go ahead and try, let's just do, because I have 1 and 2 up here right now. Go ahead and try 1 and 2 on your own, and then come on back and we can look at it together. Look at them together. Okay, I'm going to go ahead and just solve this number one with you first. So it asks us to find the radius of the following circle if the circumference is 37.68 inches, and it wants you to use pi as equaling 3.14. Now, following circle, I'm not sure exactly what they're talking about, because I don't see any circle, but I guess they're talking about, better would have been better, find the radius of the circle that has a circumference of 37.68 inches. Okay, so let me go ahead. I'm just going to show you. I'm going to turn this on here, and we'll start solving that. Okay, so some things I wanted to, what I first did is went ahead and, let's slow that down a little bit. Went ahead and just circled what I was looking for, right? What I know. I had circumference is 37.68 inches. I'm using 3.14 as pi, and I'm looking for my radius. Okay, so what I know is C equals 2 pi r. Okay, I know, and then what I do know is that my C is 37.68 inches. My 2 and my pi is 3.14. And then my R, that's the question mark. Okay, so when we're solving this, so now I've gone from my this here, my formula, to this here, and now I have it somewhat in a formula, and I've entered every known that I have, and just left my one unknown, which is the R. Okay, so it's just about solving an equation. So let's watch that happen. So what I'm going to do here is I'm going to go ahead and I'm multiplying the 2 times the 3.14, and that's how I got the 6.28R. Okay, so that was these, multiplying this, the 2 times the 3.14. Again, it's commutative, so I can multiply any of these numbers in any order I'd like. Okay, and then I get 6.28R. So now I'm down to this in its simplest form, and now you can see what I'm starting to do. I am starting to solve. Now I have my I do have my unknown, or my variable, on the right side. Not optimal, but I'm keeping it there because I don't care, because I like it there. It's going to make my life simpler. But actually, you can see what's happening. You'll recognize the 1.628, 1 over 6.28 is a reciprocal of 6.28 here. And so just go ahead and watch what I do here. So okay, we're going to multiply each side by that reciprocal to try to get our variable to 1. Okay, and we'll come up with 6 equals R. Okay, or R equals 6, same exact thing. Okay, very, very nice and friendly problem because 37.68 divided by 6.28 just happens to be 6. So very, very friendly. So we have solved this problem. Okay, and if we went ahead and then plugged in our numbers to prove what we just done, okay, we look to this original formula to help us out. So that means 37.68 should be equal to 2 times 3.14 times 6, and if you do the math, that works out. So yeah, 37.68 is equal to 37.68. All right, so that checks out. Okay, so that is number 1. Hopefully, again, it's just a matter of plugging numbers into formulas. Maybe some of you forgot the formula, but this is our circumference formula from lesson 16. Okay, so yeah, so let's go ahead and do number 2. Have you do number 2? Maybe you've done it already, but if you want to take another look at it, you can come back after I pause here. So it says determine the area of the rectangle below. Okay, that's this rectangle here. And name 2 ways that can be used to find the area of the rectangle. Okay, name 2 ways that can be used to find the area of the rectangle. Okay, so don't do any solving yet. Just tell us 2 ways that you could do it. Okay, so I did indeed solve the problem. Of course, I mean, it's kind of goes along with the explanation of it. But there are 2 ways to do this, and again, we're going to be talking eventually about the area of a circle, but starting with the area of this rectangle is something that we all probably know already. Okay, so if we go ahead and do look at it, let's see, we're going to erase that first. And then we have a 6 centimeters by 4 centimeters. Okay, so 6 centimeters length, 4 centimeters in height. And what most of us know, is that we multiply those 2 numbers to get 24. Oopsie, I don't want to do that quite yet. 24 square centimeters. And really, really important that we have 24 square centimeters, okay? Because this is like any kind of multiplication array. If you've done arrays, dot arrays, you have a 3 by 5 dot array, for example. 3 three columns of 5, and that would be 15. It's a multiplication problem in essence. Okay, it's truly what it is. And actually the next solution will show you that a little bit more clearly. Again, square centimeters, okay, or centimeters squared, okay, is because each of these is a centimeter by a centimeter, and it is a centimeter squared, or a square centimeter. Okay, each one of those little squares. And another way to do it is just to count them. Square centimeters. Okay, and then there we go. So that's 1 centimeter by 1 centimeter. Okay, each one of those little squares is 1 centimeter by 1 centimeter. So it's a square centimeter, or a centimeter squared. Okay, when I counted those were 24. Okay, so 24 square centimeters. And hopefully everyone is comfortable with that. Okay, so the last problem here is this number 3. Okay, and it asks us to find the length of a rectangle if the area is 27 centimeters squared and the width is 3 centimeters. Okay, so we can, so go ahead and solve that one and come on back, check it. Okay, so we just would proceed with this problem, similar to the way we did the circumference problem in the first exercise we did here. We have our formula, area equals length times width. Many of us know that. And here's what we know already. We know 27 square centimeters, and then 3 centimeters in length. And if we write it out, then we know that 27, plugging in what we know already, so we know 27 equals L times 3. I know many of you know the answer already, but just to apply our algebra knowledge to it, of course we're going to multiply by the reciprocal, just to show you that this is how these things work, and what we're doing, you guys have done so often already. And I just fill in my centimeters. I'll make sure I have my units in there. Okay, yeah, and there we are. We have 9 centimeters equals L. And again, if we plug that in over here, 27 equals 9 times 3. And that is right, 27 equals 27. Okay, again, just checking, just knowing that some of these numbers are going to get more and more complicated. Okay, so it's kind of a little bit of a refresher, just to see who remembered area and the formulas, and hopefully everyone fared well there. Okay, so this exploratory challenge here is, part of it is to actually take a circle, divide it into 16 equal sections, and have you guys, cut it out and try to reassemble it as a rectangle, which could be lots of fun, but it would take a lot of time, and I'm not quite sure it's necessary. Again, I'll refer you to that video that is posted at the website. It will be posted underneath this lesson because it is really, really interesting, and they go through that whole process, and it's really, like I said, it really is fun and very, very enlightening to watch. I'd advise, if you don't understand it first, go back and play it again, pause it whenever you need to, but very, very interesting to see this relationship between a circle and a rectangle really come to life in this animation. Really, really, it's much better than anything I could ever show you. But yeah, real aha. Anyway, so we're trying to find the formula for the area of a circle, okay, and that's what they're getting to. And there's going to be a very standard formula, but to see where it comes from is very, very interesting. All right, so if we went ahead and took these and cut them out, we could arrange the triangular wedges by alternating the triangle directions and sliding them together to make a parallelogram, okay, and it doesn't really look this good. I can tell you, and it never can. It's just so difficult. And you see what happens if you take these are all these parts here, okay, all those sections, and This is all these sections kind of showing you. When you slide them together, you would see that this is going to be too big here, and this is going to be too big here. So what you do is you cut this one here, and then add it right here. Okay, and that's what you would do right there. So yeah, and if you look at this, you can see, and it says if you can take a look, and you can see what some of these this rectangle here. Okay, kind of a rectangle. So we have, excuse me, they've turned this into this, okay? And again, it's an approximate rectangle. Again, very, very difficult. The animation that you're going to watch looks perfect, okay? And something only a computer could do. Now, if you look at this measure right here, up and down, okay, in this rectangle, is the radius, because you can see, and again, these aren't the correct, this one and these here are not done to scale, so they don't exactly look the same, but you can see how that would be the radius, because that line right here, okay, so that would be a line of radius right here, okay, if we looked at that as a rectangle. And now what you understand, maybe you can think of it in terms of how do you find the area of a rectangle. You multiply the height times the length, okay? And you can see how this radius, in this case, kind of stands for, or is represented, or represents the height of this rectangle, okay? Is that radius right here, okay? And let's just move on. And then, okay, that's that part, yeah. And so then we saw that, and then down here we're looking. So if we know that the circumference is 2 times pi times r, where the radius is r, therefore half the circumference is pi times r. Okay, so pi times r. So this section right down here is pi times r right here, which is half of the circumference, okay? Pi times r, because circumference equals 2 pi times r, okay? And that says, and we know that right here, okay, if that is the case, because this is just half right here. This length from there to there, excuse me, is just half of the circumference, okay? So what is the area of the rectangle using the side lengths above? What would the area of the rectangle be using the side lengths above? So take some time to think about that, and come on back and we'll talk a little bit more about it. Now, one thing I didn't mention before we answer those questions over there is why this is half the circumference. Okay, half the circumference. And if you'll see this line right here, these lines, that is this. Right? Let me get a different let me get a different color, and we can show you here. So this right here is actually this. Okay, it's that line. Okay, right there, that part of the circle, because these are all the the edges of the circle right there. Okay, so that's only half. So when you put this together as a rectangle, your your length or your base is only half the circumference. Okay, so that's why that is considered half the circumference. Just wanted to clear that up. Okay, so yeah, so the idea here is what we wanted to talk about here was what is the area of the rectangle using the side lengths above, and the side lengths they're talking about are the r and the pi times r. Okay, we've created these sides. All right, so let's just take a look at that. So so C equals 2 pi r. Okay, Now we are only talking about half of that circumference, okay? Half of that circumference. So if C equals pi r, pi square, 2 pi r, then that line right there is equal to pi r. Okay, is equal to pi r. Now we also know the area is length times width. Okay, so area is length times width. So we are going to now use that area formula and plug in what we know, because we know that in this case the area equals pi times r, which is that, times r, which is that right there. Okay, so we've just used the area formula, and for length and width we plugged in pi r, and then r for the width. Okay, so yeah, so now we have that. Alrighty, so let's go ahead and are the areas of the rectangle and the circle the same? That's the question. You may have answered that already. The same, and when you come back, maybe you will have written down some reasoning as to why you believe it is or is not. Okay, so come on back when you think about that for a bit. Okay, so yeah, the answer to this question here, are the areas of the rectangle and the circle the same? Hopefully you thought that they were indeed yes, because we have we've just rearranged the pieces. Okay, we've just rearranged them. I'm going to rearrange that. I'm going to replace that, remove that, relocate that. Okay, yeah. So we have just rearranged pieces. Very important. We have not lost, nor have we gained any. Okay. So we haven't lost or gained any pieces. We've taken it from this circle here, right here, and we've rearranged those pieces to create this rectangle. Okay, so therefore the area, all of the space inside here, is going to stay the same because nothing has changed in terms of area. Okay. So here, so it says if the area of the rectangular shape and the circle are the same, what is the area of the circle? Okay, and the idea here is, how do we show, or how do we represent the area of the circle? So if you know, I'd like for you to try and just have go A equals, and I want a little formula here. If you remember your formula for area of a circle, come on, after you've written it down, come on back. If not, just hang on, we'll get right to it. Okay, so here we go, area of a circle. Pi r times r, or area of a circle equals pi r squared. Okay, oops, didn't mean to do that. Let's go back there. Yeah, pi r squared. And hopefully you remember where these came from. If we go back to our other slide, they're right here. Here's r, right here is our r, and here is our pi times r. And again, the magic of multiplication, we have pi r times r. We could also write that as pi times r squared. Okay, because we are multiplying, we can go ahead and multiply these two. They are the same. If you have two r's, you can multiply them together, and if you multiply r times r, you get r squared. Okay, and that is the case, that would always be the case in terms of when you have like variables in that case. All right, when we're multiplying, and we'll see more of that in the future. But anyway, just to kind of cut to the chase there, this is our magic circle area formula. Okay? And we'll go ahead and we'll be using that to solve problems in a little bit. But let's go ahead and look at this example 1. Now here is another way to approximate, again using a grid here, to approximate the area of a circle. Okay? So what I want you to do is I want you to go ahead and use the shaded square centimeter units to approximate the area of this circle down here. Okay, and then also go ahead and answer this question. What is the radius of the circle? And there are other questions. Just go ahead and do those two first. Come on back and we'll hit the next ones. Okay, so let's go over this this problem here. Now, a couple of things. For one thing to notice first is, each one of these little squares is 1 centimeter by 1 centimeter, also known as a square centimeter. Okay, yeah. So, in order to approximate the area of the circle, they've done something very convenient for us. They've actually made this one here, and that is like approximately 1/4 of this circle. Okay, and we're looking at it in terms of its square pieces, ignoring anything that ignoring the fact that we got some space here, space there, and there's too much here, etc., etc. Okay, so take those out, and what we do is we would just go ahead and count our squares very quickly. Of course, I didn't do it this quickly. It's just going that quickly. Very interesting. And that turned out to be approximately 79 centimeters. And as I mentioned before, there are 4 pieces, 4 quadrants to this circle. And if each had 79, then we would just go ahead and multiply that 79 square centimeters there by 4, and we would end up with 316 square centimeters, or centimeters squared. Okay, and the radius, of course, is just one of those each one of those lines that starts at the center and ends. It's a segment, line segment, starts in the center and ends at the edge of the circle, and those are 10 centimeters long. So the radius of the circle is 10 centimeters. Okay, so now the next thing that is asked here is what is the what would be a quick? Okay, so actually, you know what? These other questions here have kind of answered. The first they asked you about what was the radius, and then what would be a quicker method, and that method was the one that I showed you here. Was taking the one section and adding up those squares, get that approximate 779, and then multiplying that by 4 pieces. That's pretty much what they were getting to. Okay. Now using this next one here, it says using the diagram, how many square? Okay, so yeah, the rest of these questions don't really apply. Just what I did before is all we need to really pay attention to. Okay, and then the area of the entire circle, we already did that, and that was 316 centimeters squared. Okay, again, just a way to approximate the area of a circle, and just to show you when we talk about area, we're talking about everything in that resides inside of that circle. Looking at it in squares, okay, it was a little tedious just because some squares ended up outside of the circle, etc., etc. Okay, so let's go ahead and just move on forward with example 2. And example 2 now is a word problem that we are going to apply our newfound knowledge to. Okay, so a sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. The question here is, what is the area of the circular region covered by the sprinkler? Okay, and express your answer to the nearest square foot. And one of the hints here is to draw a diagram to assist you in solving the problem. Okay, and I'll come back and I'll ask you, well, let's just do this together. I guess we could just do this together right now, actually. Go ahead, try, see what you can do and come on back. Okay, so let's go ahead and draw this diagram that will help us solve this problem. We'll see it a little bit more clearly. So there's our sprinkler, okay, right there, that blue dot. It's a sprinkler, and if any of you are familiar with sprinklers that actually move, let's fill all this in first, that move in a rotate around. They are moving around that way. Okay, so the sprinkler itself moves around, and then it sprays out, as you can see in this case, a 12-foot spray. Okay, 12-foot spray, and then it's going to continue to spray that 12 feet as it goes around in the circle. So its spray, the length of that spray stays consistent. Okay, so this is a very practical problem here. So it stays. So it's going to cover. Now its spray is going to cover a certain region, and in our picture right here, that region is represented by the highlighted area. Okay. And now that distance of 12 feet, that would be our radius. Okay, that would be the radius of the sprinkler, and also the radius of this circle we have now drawn. Okay. Now the next question here is, what information is needed to solve the problem? Well, we have a few things here. We're trying to find the area of the circular region, and that's all that highlighted part. We know that we have a formula for area of a circle, which is A equals pi times r squared. Okay, that's our area of a circle. All right, we know that because we've learned about it and we've seen why that is, and we've done that already, and we know that super duper shortcut is area of a circle equals pi times r squared. Okay, we know pi is 3.14, and we know that our radius is 12 feet. Okay, so we have the radius there, we have pi there. So all we need to do is plug that into the formula, and that would be pi times 12 squared. Okay, and that is the information we need to solve the problem. Now if we just go ahead and do our calculations, okay, we know that 3.14 would be times 12 squared is 144, and if we did go ahead and put this into a calculator, we're looking at approximately 452 feet squared. Okay, so that means if we were to draw a grid inside this area, and these squares were 1 foot by 1 foot, okay, this isn't of course to scale, there would be 452 of those 1 foot by 1 foot pieces inside that circle. Okay, and again, just the difficulty of doing this kind of thing, we can't do a very simple base times height when it comes to a circle, and that is why we're so happy to have pi at our beck and call. Okay, so let's go ahead and let you go at this example 3 on your own. Suzanne is making a circular table out of square pieces of wood. Could happen. The radius of the circle that she is cutting is 3 feet. How much waste will she have for this project? Very, very interesting problem. Express your answer to the nearest square foot. Draw a diagram to assist you in solving the problem. What does the distance of 3 feet represent in this problem? So, I'd like you to go ahead and give this a whirl. It might not be easy or obvious for many reasons, but when you come back, I'll show you how I went ahead and did this problem. Okay, so let's see how your diagram compares to mine. So I drew this circle and a square, and there's my radius I'm filling in. Okay, whoopsie. Still trying to master this. So I'm imagining that if I'm going to make a, what might have been better to have written here is something to the effect that they wanted to waste the least amount of wood possible. Because truth is, I mean, she could cut this circular table out of any size piece of square wood. But if she got this square piece of wood, as you see right here, where you get as close as possible, our circle fits as close as possible inside of that. Actually meets, you can see at all of these 4 edges here. Okay, so the waste part we're looking at here is going to be all of this when we cut it. So we're trying. The question here is how many square feet is all of this worth? Okay, and it's real interesting because it's really actually quite a bit of fun when you have all the tools you need. So what information do we need to solve the problem here? Of course, we need to know 2 things. We want to know the area of the square. Okay. And then we also want to know the area of the circle. Okay. So we have enough information here that we can figure out both of those. Okay. So I'm going to leave it at that for now, and have you go ahead and try to figure this out if you have not yet done so. Try to answer that question. How much waste will she have for this project using my diagram? If you want to go ahead and draw that yourself right now, and knowing that you're going to need 2 things to solve this. You're going to need the area of the square and the area of the circle, and then I'm hoping you'll know what to do from there. Okay, so go ahead and give it a whirl and come on back. All right, so welcome back. Let's go ahead and see how you did, finding out the area of the square and then the area of the circle, and see what you did with those 2 numbers, and if you were able to come up with the answer to how much waste will she have for this project. First, we know that the square is going to be 6 feet 6 feet wide and high. Okay. Because you have, the radius there is 3 feet of that circle. Okay, therefore you're going to have another radius right next to it that's also 3 feet. Put those together, we know that's going to be the square that this is being cut out of is going to be 6 feet in length, 6 feet in width, base or height, and we know how to figure out the area of that square. 6 times 6, which is going to give us 36 square feet. Okay, now the area of the circle, we know our formula as pi times r squared. Okay, and then we just plug in what we know. We know that 3.14 is pi. We know our radius is 3, and we're going to square that radius. That's going to equal 3.14 times 9. And we do that math, we come up with 28.26 square feet. Okay, so next step now, so if we know that the whole thing, the whole square, the whole piece of wood we started with is 36 square feet, and then that circle inside that we've cut out perfectly, hopefully perfectly, is 28.26 feet, all we need to do then is go ahead and do a little bit of subtraction. We take the whole area, subtract away that circular area, and we come up with 7.74 square feet of waste. That, and that, okay? Those 4 bits that we ended up spilling onto the floor equal 7.74 square feet. Okay, so these exercises 4 to 6, I'd like you to go ahead and just give them your best shot. Answer the A's and B's and C's of all of those, and then come on back and we'll look at them together before we go ahead and close this lesson. All right, so good luck. Okay, so we're going to do 4 and 5 completely right now, and then we'll do 6 together. I'd rather talk about 6 as we do it. Okay, so here we go. Let's go through this one. A circle has a radius of 2 centimeters. Find the exact area of the circular region. And you can see this thing is going a little bit faster than I wanted it to. So firstly, we go ahead and draw our circle. I have a handy circle maker, which is very convenient for me. Go ahead and plug in what we know, and that is that this is 2 centimeters here, our radius, excuse me. Okay, and we have our formula, which is the area of the circle equals pi times r squared. Okay, and we can start plugging things in here. We know that's 3.14, which is pi, times 2 squared, which is 3.14 times 4. If we do that multiplication, we come up with 12.56 centimeters squared. Okay, 12.56 centimeters squared is the area of this circle with a radius of 2 centimeters. Now, that'll be true for any circle that has a radius of 2 centimeters. You know, it's just, well, of course, makes sense, right? Okay, so let's move on to the next problem. Okay, now 5 says that we have a circle. A circle has a radius of 7 centimeters. Find the exact area, the circular region. Again, we go ahead and draw our circle and label our 7 centimeters. And go ahead and put our formula down. Area of a circle is pi times r squared. Now in this case they want us to use 22 over 7 for pi. So that means 22.7 times 7 squared, which is 22.7 times 22 over 7 times 49 over 1. Okay, 49 over 1 of course is 49. 7 squared. Okay, and then we go ahead and cross cancel here. Our 7 and 49, get 1 and 7, and then that would equal 154 over 1, or I'm not sure what I do, yeah, over 1, or 154 square centimeters. Okay, or centimeters squared. Okay, so we'll stop right there. So next, so that's our area of that circle. Now, we haven't seen this in a while. Now the question here is, what is the circumference of the circle? Okay, so let's see what you remember. If you remembered how to figure out the circumference of a circle. Circumference of a circle, if you remember, is diameter times pi. Okay, and you remember yesterday, or not yesterday, I'm sorry, but in the last lesson, lesson 16, where we saw that relationship between diameter and circumference, which was incredible with the hubcap. And hopefully you'll do this at home, like I suggested with other circular objects. Quite an amazing thing, and really helps you understand where the number 3.14 or pi came from. Okay, but here, let's go ahead and continue here. So that's 14, which is our diameter, and our diameter comes from this up here, because we know our radius is 7 centimeters, so we know another line of radius in that circle is going to be another 7 centimeters, so that radius incomplete is 14 centimeters across. Okay, that's where I get that 14 from, diameter. Multiply that by 3.14, and then we get a diameter, or sorry, a circumference of 43.96 centimeters. And just centimeters. We're not talking about centimeters squared here, because we're not talking about area. Area is going to need a square unit, whereas diameter is a one-dimensional measure, because that's just a measure around this circle going in one direction. So it just needs centimeter as its finality. Okay, so let's go ahead and do this problem here with Joan. Again, it's one of these problems: who's right and who's not right. So Joan determined that the area of the circle below is 400 times pi centimeters squared. Okay, and that's this one, this circle right over here. Okay, so what she's saying is it's 400 pi centimeters squared, and that seems like a real weird way to put it, but what they're getting to is they're trying. Well, let's just go ahead. So Melinda says that Joan's not right; she's incorrect, and Melinda believes it should be 100 pi centimeters squared. Okay, and so what they're trying to figure out here, they're trying to see if you can recognize that, of course, this 400 here, if we just go back to our formula over here, that 400 is going to stand for r squared. Okay, so who's right? Is Joan right in that radius squared is 400, or is Melinda? Okay, so let's go ahead and do this one together here. We have Joan determined that the area of the circle below was 400 pi centimeters squared. Okay, kind of a strange way to talk about it, but you'll see it in a minute. And but Melinda is saying no, she's not correct. She's saying it's 100 pi centimeters squared. Okay, and what they're getting at here is they are looking at the formula up there, which is area equals pi times r squared. Now the r squared is the 400 or the 100 that they're talking about, because we have pi already written there. Right next to it we have pi. So that is what we're trying to find out. We're trying to match which one of those, the 400 or the 100, is going to be, it's going to resemble or represent that r squared more correctly. And the way we have to do that is go ahead and look at our circle over here. Okay, in our circle we notice that that's the line of radius is the one that goes from the center of the circle to the edge of the circle. What they've given us there is actually the diameter. Okay, so they've given us the diameter is 20. Therefore, if we know that diameter is 20, we know the radius is 10, because the radius is half of the diameter. Diameter is 2 times the radius. Okay, so if we go ahead and do that, we just put our formula out there again. We have pi times r squared. 100 would be 10 squared, so that would be pi times 100, or 100 times pi. Okay, and we can see who is correct, and we have Melinda being correct, because that was her prediction right there. Yes, so I'm sure you'll be seeing more of those problems in the near future, and hopefully you will tackle them with vim and vigor. Okay, so in closing this lesson, and I think lesson 18 will also be on area of a circle. So we'll work a little bit more. Actually, lesson 18 is going to be more problems with on area and circumference, which is nice. Kind of give us some more time to practice with those. But we talked about not only definitions of area of a circle in this lesson. We also talked about the formula. And where pi and where the pi r squared came from. And again, concerning that, please do check out that video. That will be at the website underneath this one, which is, I think, quite fascinating, and I'd love to get your feedback on it. We also talked about some strategies for problem solving and some good strategies in this lesson was drawing diagrams. Okay, so drawing the diagrams to represent the problem. Okay, and that was very handy. And then also in identifying the given information and needed information to solve the problem. Okay, because we know we had our area of a circle is pi r squared. We had our formulas, so we had to identify what in the problem we should plug in for radius at some point. We knew pi, of course, area. So again, identifying those given information and how to use it to solve, very, very important. Okay. So once again, this relevant vocabulary, I don't feel like going over that because it's just really weird. But anyway, just talking about the area of the circle. Of course, the circle is the boundary of that disk. Okay, boundary. That's the circumference there, but that is the circle itself, and inside that circle, all encompassing inside there is the area of that circle. Okay, which is something I think most of us, if not all of us, are well aware of. Okay, so go ahead. Good luck on the problem set and the exit ticket, and see you at lesson 18.